So we're looking at the limit as x goes to 0 of sine of 1 over x, and we want to show that that's undefined. So let's kind of look at, I want to kind of talk to you about this. So if we have x goes to 0, and we have 0 in the denominator, so 1 over some number that goes to 0, right? So let's think about it. If you have 1 over 10, right? This is 0 0.1. It's 1/10. If we have 1 over 100, this is equal to, what am I trying to get to you? 0.01, it's 100th. So as x is actually going to 0, notice that this number is actually going to infinity. So because I have 1 over like 1/10, and this is 10, or 1 over 1/100th. This is equal to 100, or 1 over 1,000th. This would equal 1,000, right? And so as our value of x goes to 0, this is really sine of going to infinity. So another way that we can kind of write this is the limit as x approaches infinity of sine of x. Well, it really depends on, are we looking at the left or the right, right? Because if I was choosing, and let's say I'm looking at the limit as x is approaching 0, in this case, on the right-hand side of sine of 1 over x. Because these are positive numbers that I'm plugging in. If I had looked at this though, and I was looking at what happens when I plug in negative numbers that are close to 0. So let's look at the limit as x is approaching 0 on the left-hand side of this sine of 1 over x. So when I'm plugging in negative numbers close to 0, so negative 0.1, negative 0.01, those are actually going to go to negative infinity. And so this is looking at the limit, same kind of idea, as going to negative infinity of sine of x. If you recall though, when you're looking at your sine function, right, just oscillates back and forth. And the range, right, those range is between -1, oh, it hits down there, and 1. So the y values that we're getting back are bouncing in between and including -1 and 1. There's no one particular value that that function is going to. And so because it's not going to one particular y value, we can say that this limit doesn't exist. So therefore, the limit as x is approaching 0 of sine of 1 over x does not exist. And the reason why is, if we look at this function, sine of 1 over x, what's happening as we're getting closer and closer to x equals 0 on the left and the right, it's starting to oscillate really, really fast back and forth between -1 and 1. And there's no value, y value, that it's particularly going for towards. So therefore, the limit as x approaches 0 of sine over 1 of x doesn't exist because of oscillation. So let's see if I can pull up the picture of that. Let's graph it and show it. I just pulled up Desmos. I just plotted the function we were looking at, sine of 1 over x. And so notice as x is getting closer and closer to 0, that's oscillating back and forth so fast that there's no one particular value that we can say it's approaching. And because we have it up, I want to look at that other function we were just looking at, right? Sine of x all divided by x. So let's change this. Divided by x. And we saw that that limit was actually 1. So here's the graph of sine of x over x. There really should be an open circle there when x is 0 because it's undefined. Can't have 0 in the denominator. But notice the limit as x is coming in on this one side is going to positive 1, and the limit as x is coming in closer to 0 on the right-hand side, we're also approaching the y value of 1. So that's looking at the graph of it. You can see those limits are what we just talked about.